Have you ever wondered how your car knows when it's overheating or running efficiently? But before we start, please don't forget to hit the like and subscribe button for more videos. Let's dive in. The secret lies in tiny devices called engine sensors. These sensors constantly monitor your engine, sending important information to the car's computer to keep it running smoothly. In this video, we'll explore the main engine sensors, how they work, and why they're essential for every vehicle. 1. Oxygen sensor. When your engine roars to life, there's a silent partner working behind the scenes to keep it clean, efficient, and responsive. Oxygen sensors, often called O2 sensors, are small but mighty components mounted along the exhaust line. Their job? To measure the amount of oxygen in the exhaust gases as they exit the engine. Most modern vehicles have two types: upstream sensors, before the catalytic converter; downstream sensors, after the catalytic converter. The upstream sensor, located before the catalytic converter, monitors the air-fuel ratio coming out of the engine. It sends real-time data to the engine control unit, or ECU, helping it adjust fuel injection for optimal combustion. Why does this matter? Because your engine's performance depends on the air-fuel ratio. Too much fuel and you waste gas. Too much air and the engine runs lean. Oxygen sensors help the engine control module, or ECM, adjust fuel injection in real time. Each sensor sends voltage signals to the ECM. A rich mixture, more fuel, produces low oxygen and high voltage. A lean mixture, more air, means high oxygen and low voltage. The ECM reads these signals and tweaks the fuel delivery to keep things balanced. Downstream sensors monitor the efficiency of the catalytic converter. If the converter isn't cleaning up emissions properly, the sensor will detect it and trigger a check engine light. Faulty oxygen sensors can lead to poor fuel economy, increased emissions, and sluggish performance. Replacing them is a smart move and often a simple one. So next time your check engine light flickers on, remember, those little oxygen sensors might just be trying to tell you something. 2. Coolant temperature sensor. This tiny device sits near the engine or sometimes on thermostat housing, constantly measuring the temperature of the coolant flowing through your system. As the engine heats up, the sensor sends signals to your car's computer. If the temperature climbs too high, it triggers a warning or even activates cooling fans. Most engines run safely between 75 and 95 degrees Celsius. But once it hits 100 or more, it's time to pay attention. If your readings are off or your car overheats unexpectedly, the sensor might need replacing. It's a quick fix, but a crucial one. Coolant temperature sensors, small, smart, and essential for keeping your engine cool and your ride smooth. 3. Mass airflow sensor. The mass airflow sensor measures the amount of air entering the engine. This data helps the engine control unit, ECU, determine the correct amount of fuel to inject, ensuring optimal combustion, performance, and fuel efficiency. It's usually located between the air filter and the throttle body. If this sensor fails, you might notice poor fuel economy, rough idling, or even a check engine light. Most MEF sensors use a heated wire or film. As air flows past, it cools the element. The sensor measures how much current is needed to keep it hot, and that tells us how much air is coming in. 4. Throttle position sensor. The throttle position sensor, or TPS, is a vital component in your vehicle's fuel management system. It monitors the position of the throttle valve and sends that data to the engine control unit, helping regulate fuel injection, ignition timing, and overall engine performance. You'll find the TPS mounted directly on the throttle body, typically near the intake manifold. It's connected to the throttle shaft, right where the throttle plate pivots. 5. Crankshaft and camshaft position sensor. The crankshaft position sensor monitors the rotation of the crankshaft, the part that converts piston movement into power. It tells the engine control unit, or ECU, exactly when each piston hits top dead center. The camshaft position sensor tracks the camshaft's rotation, which controls valve timing. This helps the ECU sync fuel injection and ignition with precision. Together, these sensors keep your engine's timing perfect. If either fails, you'll notice rough starts, misfires, or even a no-start condition. 6. Knock sensor. It bolted directly to the engine block. This sensor detects the telltale signs of abnormal combustion, known as knocking or pinging. The knock sensor uses a piezoelectric crystal. When it feels the vibration, it generates a voltage, an SOS, to the engine's brain. The engine control module receives the signal and instantly retards ignition timing. This reduces pressure and stops the knock in its tracks. So, thanks to this tiny sensor, your engine runs smoother, lasts longer, and burns fuel more efficiently. Last, manifold absolute pressure sensor. Every time you press the gas pedal, a symphony of sensors awakens beneath the hood. Among them, one plays a silent but vital role in orchestrating engine performance: the manifold absolute pressure sensor, or MAP sensor. The MAP sensor measures the pressure inside the intake manifold. Why does that matter? Because pressure tells us how much air is entering the engine, and air is everything. It's the breath of combustion. By reading manifold pressure, the MAP sensor helps the engine control unit, your car's brain, calculate the perfect air-fuel mixture. Too much fuel, you waste gas. Too little, you lose power. The MAP sensor keeps it balanced. Physically, it's small and unlike mass airflow sensor. It located between throttle device and intake manifold. Just a chip with a diaphragm and circuitry. But its job is massive. It converts pressure into voltage, sending real-time data to the ECU. From idle to full throttle, it's always listening. Typically, a MAP sensor outputs between 0.5 to 4.5 volts. That range corresponds to pressures from 10 to 250 kilopascals. The ECU reads this signal and adjusts ignition timing, fuel injection, and even turbo boost. When the MAP sensor fails, symptoms appear: rough idling, poor fuel economy, sluggish acceleration. It's like trying to breathe through a straw. Your engine struggles without accurate pressure data. So next time your engine purrs perfectly, remember the quiet guardian watching every breath. The MAP sensor, small, precise, and essential to the rhythm of the road. How they work together. All these sensors work together, sending data to the engine control unit, or ECU. The ECU acts like the brain of the engine, making split-second adjustments to fuel, timing, and airflow. Thanks to these sensors, your engine runs efficiently, safely, and reliably every time you drive. Even though they are small, engine sensors play a huge role in keeping your car healthy and efficient. If you want to learn more related contents, hit the subscribe button and stay tuned for our next video.